Okay, good afternoon, good morning. So, in morning previous session, we have discussed about the 4-bar chain and inversions of 4-bar chain and single slider crank chain in previous video. Now, we are going to discuss about inversions of single slider crank chain. So, different inversions are possible. So, one by one we will discuss now. So, single slider crank chain is a 4-bar mechanism or 4-link mechanism. Okay, it is also having 4 links which are having one slider and remaining are one sliding pair, 3 turning pairs are there. Then it is called a single slider crank chain. Now in this, by fixing different links in different positions, okay, different mechanisms were obtained. That is inversion of mechanism. 4 inversions of a single slider crank chain are possible. 4 inversions are possible. First one is pendulum pump or bull engine. Pendulum pump or bull engine. So in this mechanism, the inversion is obtained by fixing the cylinder or link 4 sliding pair as shown in figure. Okay, link 4 is fixed, and then in this case crank rotates, the connecting rod oscillates about a pin pivoted to the fixed link 4, and the piston at the piston attached to the piston rod reciprocates. So in this case, duplex pump which is used to supply feed water boilers have 2 pistons attached to link 1. Okay, this is the duplex pump which is used to supply the feed water to the boilers. So this type of pendulum pump or duplex pump is used. So in this case, we are observing crank is rotating, then connecting rod will be oscillating. As the connecting rod oscillates, the piston rod will be reciprocating as the cylinder is fixing. So these are the 4 links. One is the sliding pair, only one is the sliding pair, that is piston rod will reciprocate or piston rod reciprocating with respect to cylinder, that is sliding pair. Remaining are the turning pairs, that is crank 2 with respect to fixed element is rotating and connecting rod will be oscillating. Okay, kinematic turning pairs, these are the remaining are turning pairs. 3 are the turning pairs and only one is the sliding pair. Okay, now next coming to the oscillating cylinder engine, second one. So in this case, cylinder will be oscillating, that's why it is called as oscillating cylinder engine. Okay, in this to convert reciprocating motion into rotary motion, in this mechanism the link 3 forming the turning pair is fixed. So connecting rod is fixed of a reciprocating steam engine mechanism. The link 3 corresponding to the connecting rod of a reciprocating steam engine mechanism, we are fixing. When the crank rotates, the piston attached to the piston rod reciprocates and cylinder oscillates about a pin pivoted to the fixed link. Now we are observing this figure. As the connecting rod is fixed, okay, crank will be rotating, okay, therefore cylinder will be oscillating. Okay, piston rod, because as connecting rod is fixing, crank will be rotating. As the crank rotates, cylinder will be oscillating. Okay, this is there are 4 links. Piston rod, piston is the one link, cylinder is the another link. Okay, cylinder is the another link, connecting rod is another link, and crank is the another link. So these are the oscillating cylinder engine mechanism. So one of the inversion of the single slider crank chain. So another one is rotary internal combustion engine or GNOME engine. GNOME engine or rotary internal combustion engine. This engine was used in olden days in aviation or aircrafts. Nowadays it is replaced with gas turbines. Okay, nowadays we are not using these rotary IC engines. Olden days it was used in aircrafts. Now in this case 7 cylinders are there in one plane and all are revolve about fixed center D. So, okay, that figure I will show you later in the next slide. So now crank 2 is fixed. Okay, crank is fixed in this mechanism. When the connecting rod rotates, the piston reciprocates inside the cylinder forming the link 1. Okay, now the cylinders are, you are observing, cylinders are link 1 and fixed link is connecting rod, crank. Connecting rod will be rotating as piston will be reciprocates. Okay, these are the way we are moving. Connecting rod is rotating, piston is reciprocating, and cylinder is fixed. Crank is fixed, cylinder will be rotation. Okay, this is the way we are taking in this portion. Okay, this is called as rotary IC engine, or we can call as GNOME engine. Okay, 7-cylinder engine we can used. Okay, this was used in the aviation. Now next one is another inversion, crank and slotted lever kick return motion mechanism. Crank and slotted lever kick return motion mechanism. In this figure we are observing, okay, this mechanism is mostly used in shaping machines, slotting machines, shaping machine and slotting machines are mechanisms are crank and slotted lever kick return motion mechanism. So and in rotary IC engines also it may be used. Okay, rotary engine, the mechanism, the link AC forming the link turning pair is fixed. Okay, the link 3 correspond to the connecting rod of a reciprocating steam engine. The driving crank CB revolves with uniform angular speed about the fixed center C. A sliding block attached to the crank pin at B slides along the slotted bar AP and thus causes AP to oscillate about the pivoted point A. So that figure I will show you. So short link PR transmits the motion from AP to the ram, which is carries the tool and reciprocates along the line of the stroke R1 R2. So the line of stroke of the ram R1 R2 is perpendicular to the AC produced. Okay, this is the observing. Okay, now in the extreme positions AP1 and AP2 are the tangential to the circle and cutting tool is at the end of the stroke. Okay, the forward or cutting stroke occurs when the crank rotates from the position CB1 to CB2 in the clockwise direction. So the return stroke occurs when crank rotates from CB2 to CB1 in the clockwise direction. Since crank has uniform angular speed, therefore time of cutting stroke by time of return stroke is beta by alpha. The angles time of cutting stroke by time of return stroke is beta by alpha, or beta by 360 minus beta, or 360 minus alpha by alpha. So this is the figure you can observe. Okay, now before taking the figure, so this is traveling distance or length of the stroke. Okay, traveling distance, travel of the tool or length of the stroke is R1 R2, that equal to P1 P2, that equal to 2 P1Q, that is nothing but 2 AP1 sin angle P1AQ. So that is angle P1AQ nothing but 90 minus alpha by 2. So sin 90 minus alpha by 2 is cos alpha by 2. So this you are substituting 2 AP cos alpha by 2 nothing but 2 AP into CB1 by AC, or 2 AP into CB by AC. This is the value you are calculating, time of cutting stroke by time of return stroke value ratio. So this is the figure you are observing. So fixed link 3. Okay, slotted bar is the link 4 and piston or slider is the link 1 and crank is the link 2. So now we are observing link 3 fixed. As the connecting rod is fixing, slider is moved, reciprocates are along the slotted bar. So as the slotted bar, the slider is oscillating or sliding along the slotted bar as the crank rotates. So then slider will be or slotted bar will be oscillating. Okay, that oscillation from AP1 to AP2, then at the end point of the slotted bar, we are connected by means of connecting rod to the ram, which is a tool is attached to that. As the tool is moving from R1 to R2, cutting will be taking place. R2 to R1, return stroke will be taking place. So whenever the crank is moving from CB1 to CB2 in clockwise direction, cutting is taking place. From CB2 to CB1, return stroke is taking place. That's why alpha is the angle turned by the crank in the return stroke. Beta is the crank angle turned by the crank in cutting stroke. Therefore, time of cutting stroke by time of return stroke is nothing but beta by alpha, or 360 minus alpha by alpha, or we can write as beta by 360 minus beta. Anyone you can write. So that is the way you are calculating. So now length of the cutting stroke is nothing but R1 R2. R1 R2 equal to P1 P2, that you are writing as 2 P1Q. So P1Q nothing but 2 into AP1 sin angle P1AQ, that's you are substituting 2 AP1 sin 90 minus alpha by 2. So then 2 AP into cos alpha by 2. Cos alpha by 2 is nothing but CB by AC, that you are writing CB by AC is cos alpha by 2. Then you are simplifying that equation, you got it the value that time of cutting stroke by time of return stroke and length of the cutting stroke are calculated. The angle made by the forward or cutting stroke is greater than the angle described by the return stroke from the figure you can observe. So therefore, return stroke, the crank rotates with uniform angular speed. Therefore, the return stroke is completed within shorter time. That's why it is called as quick return motion mechanism. Okay, this is one of the inversion of the single slider crank mechanism. Next inversion is Whitworth kick return motion mechanism, is another inversion. Okay, this mechanism is mostly used in shaping and slotting machine. In this mechanism, the link CD forming the turning pair is fixed. Okay, in this link CD is fixing, so link 2 correspond to a link crank C in a reciprocating steam engine. The driving crank CA rotates at a uniform angular speed. Okay, the slider attached to the crank pin at A slides along the slotted bar PA, which oscillates about at a point D. The connecting rod PR carries the ram at R, to which a cutting tool is fixed. The motion of the tool is constrained along the line RD produced along a line passing through the D and perpendicular to CD. So this is the Whitworth kick return motion mechanism. You can observe. So fixed link CD and driving crank, this CA is the crank, and slotted bar is the link 1 and slider is the another link 4. So now this is connected to the slotted bar is connected, end of the slotted bar is which is connected to the connecting rod to the tool ram. Okay, this tool is moving perpendicular to the CD as moving from R1 to R2. Cutting is taking place, R2 to R1 will be, return is taking place, cutting stroke and return stroke is taking place. This is the called as Whitworth kick return motion mechanism. Okay, this figure have to be clearly explained from this. Okay, CD is the fixed link, driving link is the AC. As AC is rotates, okay, slider is A is sliding in the slotted bar. As slotted bar is oscillating, so therefore which is connected to the connecting rod of the ram. So therefore, as the slotted bar oscillates, so connecting rod will be oscillating. Okay, therefore the ram will be reciprocates. Okay, therefore R1 to R2 it will sliding, cutting, and R2 to R1 is return stroke is taking place. So from this condition we can write from this figure Whitworth kick return motion mechanism. When the driving crank CA moves from position CA1 to CA2, link DP from position TP1 to DP2 through an angle in the clockwise direction, the tool moves from left hand end of its stroke to the right hand end of the through a distance 2pd. So therefore we are writing, and the driving crank moves from position CA2 to CA1 through an angle in the clockwise direction, the tool moves back from right hand end to of its stroke to the left hand end. Like this, right to left to right is making forward and return strokes. A little consideration will show that time taken during the left to right movement of the ram will be equal to the time taken by the driving crank to move from CA1 to CA2. That's why similarly time taken during right to Similarly, the time taken during the right to left movement of the ram will be equal to the time taken by the driving crank to move from CA2 to CA1. Since the crank CA rotates at uniform angular velocity, therefore time taken during the cutting stroke is more than the time taken during the return stroke. In other words, the mean speed of the ram during the cutting stroke is less than the mean speed during the return stroke. So the ratio between the time taken during the cutting and return stroke is given by the equation alpha by beta, or alpha by 360 minus alpha, or 360 minus beta by beta. So now in order to find the length of the effective stroke R1 R2, mark P1 R1 or P2 R2 is but equal to PR. The length of effective stroke is equal to 2 times of PD. So in this way you can calculate the values So these inversions of single slider crank is over. Now in the next videos, 1 or 2 problems will be discussed on Whitworth return mechanism and quick crank and slotted lever mechanism. Then double slider crank mechanism inversions will be discussed. Thank you.